Alright, in this lesson, I'm going to show you guys how to find the exact value of a trig ratio using one of the sum or difference identities. So given this question here, we know that tan alpha is equal to 4 over 3, tan beta is equal to negative 5 over 12, and alpha is in quadrant 1 and beta is in quadrant 2. And what we want to do is find the exact value of cosine alpha minus beta. Now, to find that exact value, we do have to use one of the identities, and you just want to match it up with the proper one. So I see that it matches the form of this identity. Now, to find the exact value, we need to find out, first of all, what is the cosine alpha? What's the cosine of beta? And also, what's the sine of alpha and what's the sine of beta? Now, what I'm going to do here to find those values is go ahead and graph each angle and go from there. So, for example, for tan alpha equals to 4 over 3, we know that, we know that alpha is in quadrant 1. So here's quadrant 1 and here's my angle. Now I'm going to go ahead and create a right angle triangle here. So here's a point, drop a vertical line, and use the tan ratio to find out what the sides of the triangle are. Now remember, tan is y over x. So as you can see here, the y value is 4 and the x value is 3. So y is vertical, so this is 4, and 3 is horizontal, so that's going to be 3. Now, we don't have all sides yet. We still need to find out what the radius is, and since we know two sides of the triangle, we can go ahead and use Pythagorean theorem. So Pythagorean theorem is r is equal to the square root of each of the sides squared and added together. So I'm going to go 3 squared plus 4 squared, which will give me root of 25, which gives me a nice value of 5. So there's my r value. So if I want to find the cosine of alpha, cosine is always x over r, or adjacent over hypotenuse, and that ratio is given as 3 over 5. Okay, and it is positive because all ratios are positive in the first quadrant. And we also have the sine of alpha, which is y over r. And in this case, y is equal to 4, and r is, well, it's going to be 5. So those are all done. Let's go to the next diagram here where we're working with beta now. So beta, we know that that terminates in quadrant 2. So quadrant 2 is right there, and here's my angle beta. I'm going to do the same thing here. I'm going to use the fact that we know what tan beta is. It's equal to negative 5 over 12. So remember, tan is always y over x. So y is 5. So if I drop a vertical here, this side length is 5, and then the x is 12. Now, where does the negative go? Well, in quadrant 2, the y values are positive, but the x values are negative, so that negative actually applies to 12. So here's my diagram all set up. The only thing we need to find out here is the actual r value, so the hypotenuse. So let's go ahead and use Pythagorean theorem. So r is equal to the square root of 5 squared plus negative 12 all squared. That gives me a value of 169, and the square root of 169 is a nice whole number of 13. Okay, so now we can go ahead and fill in the missing pieces here. Cosine of beta is x over r, which is negative 12 over 13. Next, we have the sine of beta, which is y over r, and that is 5 over 13. Okay, so let's go ahead and find the exact value now using this identity. So cosine alpha minus beta is equal to cosine alpha times cosine beta plus sine alpha times sine beta. Okay, so we just go ahead and fill in each ratio. So cosine alpha, we did find that value. It's 3 over 5, so that goes first. Cosine beta, we also found that value. That is negative 12 over 13. Then we're going to add sine alpha, which is 4 over 5. And finally, sine beta, which is 5 over 13. Okay, so we just simply, we simplify from here. So 3 times negative 12, that's going to be negative 36 over 5 over 13, which is 65, plus 4 times 5, which gives you 20, over 5 times 13, which is, again, 65. So same denominator, so this is easy adding here. So negative 36 plus 20 finally gives me a value of negative 16 over 65. So there is the exact value.